Okay, in the next set of problems, we're no longer dealing with simplifying expressions. Now we're talking about solving equations. And so for this, we have a very simple equation. We want to isolate the x. To do that, we have to get rid of the negative 5. Since the negative 5 is multiplied by x, we're going to have to undo that by dividing. We divide both sides by negative 5, and we end up with x is equal to positive 5. And so that does it for number 5. Alright, with number 6 we have 2/3 x is equal to 18. So this says 2/3 of what number is 18? And so we can there are a number of different ways that we could solve this problem. One way we've talked about is whenever you have fractions, to multiply both sides by the common denominator. And so that would work here. We would just multiply both sides by 3. And when you do that, the 3's here will cancel, and you're just left with 2x. Now you could multiply out 3 times 2 is 6 over 3, 6x over 3, which is 2x. But if you learn to save that time, that would be great. You see that the 3's cancel there, and you're just left with 2x. Then you have to multiply 3 times 18 on the other side. 3 times 10 is 30. 3 times 8 is 24. So together you have 30 and 24 is 54. Then once again, now we're just down to isolating the x, dividing both sides by 2. So x is equal to 27. And so that is problem number 6. Now there is another way we could have solved this, and so that is if we start with 2/3 x equals 18. When you just have two terms like this on either side, you can multiply both sides by the reciprocal of 2/3. So in that case, we would just multiply both sides by 3/2 right at the beginning. And if we do that, we see that 3/2 times 2/3, whenever you multiply two reciprocals together, you always get 1, and 1 times x is just x. But on the other side, we see that we have 18 over 2, and that cancels to be 9, and 9 times 3 is equal to 27. So that's also another way to do it. In this case, it works well because we don't have a lot of other terms to multiply by, but we could have used either of those methods. I just want to give you one last look to hopefully allow you to understand a little bit better what this question is asking. 2/3 of some number is 18. So if we were to take some number and break it into 3 parts, then we say that 2/3 of that number is 18. We don't know what the number is, so the whole number is x. And 2/3 of that number is going to be 18. Well, if we take 18, we can see that those two blocks are equal to each other there. So if we were to take that and say that that has to be 9, since those are equal squares there, they both have to be 9 because together they equal 18. And if they both equal 9, then that means that the third one has to equal 9 as well. And what do we have? We have x is equal to 27. So that's a graphical way or a visual way of seeing what's happening here. 2/3 of some number, so we set up a number with 3 parts, 2 parts of that equals 18. Each of those 2 parts have to be equal, so they have to both be equal to 9. And then the third part is also equal to 9. We add them all together, and we get 27. Alright, so we'll go on to problem number 7 then. Alright, with problem number 7, I'll scroll up a little bit, or scroll down a little bit, and here we have an equation that has x on both sides. And so the one thing that I like to do first, when I see an equation with x on both sides, is first decide which side am I going to leave the x on. The goal is to isolate the x. So I want to decide which side do I want to put the x on. And I always choose the side that has the smaller x value. That's what I call picking on the little guy, as bad as that sounds. And so the smaller x is going to be the 5x. So we're going to get rid of that. We're going to pick on that by subtracting 5x from both sides. And we end up with negative 3 on the left. Now don't forget, this is 6x minus 5x, which is just x. And that's going to do it for number 7. X is equal to negative 3. Just like above, we had x equals 27. Here, x is equal to negative 3. So we'll go on to number 8. Okay, with problem number 8, we also have x on both sides, but we have some other terms as well. Now, one of the things that makes algebra complicated is that we've learned so many strategies and rules, things to do, but in different situations, those strategies could be applied in different ways or in different orders. And so when I see x on both sides, I do want to find out which side my x is going to be on. But even before that, in this case, I want to see that I have two like terms on the same side. If I have two like terms on the same side, the first thing that I want to do is to simplify those, to combine them together. So you can see that you have a negative 3 and a positive 8. So before I go any further, first, I'm just going to simplify the negative 3 plus 8 to be positive 5. And that's equal to 6x. At which point, now I'm going to think about which side do I want to leave my x on. And again, I'm going to pick on the little guy, which in this case happens to be the 6x. So I'm going to subtract 6x from both sides, and I end up with an x plus 5 on the left and a 0 on the right. Now the x is already in place. I don't want to think about moving it, but I do need to move away the 5. The way I do that is by subtracting 5 from both sides, and I end up with x is equal to negative 5. So that would be the answer for problem number 8. And we'll stop this video at this point and go on to the next to problem number 9 in the next video.